Hello everyone! This practice exercise will allow us to determine the product of the roots of these 5 quadratic equations even without solving the mentioned roots. Of course, we could always get the roots of each of these 5 quadratic equations and subject them into multiplication, and we could get the product. However, we also have a separate process similar to the sum of roots. Now we are going to solve product of roots just by using the correct a, b, and c coefficients of your quadratic equation. The formula is given to us with this. The product of the roots is simply the quotient of the c coefficient and a. Again, the formula is simply the quotient of the c coefficient and a. This formula was derived from the quadratic formula x equals negative b plus minus the square root of the discriminant b squared minus 4, sorry, that's 4ac, that includes in the radicand, over 2a. We could use this representation of the roots of the quadratic equation in general form and subject them into multiplication, and we could get this formula here. But we are not going to show the derivation here. It may be presented in a separate video, so you might want to check on that later or soon as it is available. Again, we will just be sticking to what is the formula here, which is again the quotient of c and a. In short, we just need to identify the correct a, b, and c coefficients. Even without b, just as long as we have a and c coefficients, we can solve for the product. Let's start with number 1. Here in number 1, the correct coefficients are a equals 1, which is the coefficient of the leading term, or the term of with literal coefficient x squared. B here is not around, and it's not negative 81 because it's the constant, and that should be the value of c. C is negative 81. B is the coefficient, numerical coefficient, specifically for the middle term or the term with x as a literal coefficient. But in this case, it's not present, so we have here 0. Nevertheless, we are not needing the b coefficient to solve for the product of roots with this formula. So again, the formula is simply getting the quotient. Let me write it in this manner. The product for the roots, which are represented by x, is the quotient between c and a. In this case, c is negative 81 and a is 1. In short, the product of the roots for this quadratic equation is negative 81. If you're not convinced with this, definitely you could try solving for the roots of this and get their product, and let's find out if it's really negative 81. This quadratic equation can be solved using extracting by square roots because you don't have the b coefficient. We are going to transpose negative 81 here or add both sides by 81. Hence, we will get x squared equals 81. Then we take the root of both sides, and whenever you take the root of any number, any constant, please don't forget the plus minus sign. So the roots here are given to us by plus minus, which is the square root of 81, which is 9. So our two roots are 9 and negative 9. And if we are going to multiply the two roots, again, our two roots are positive 9 and negative 9. And if we're going to multiply them, you will get a result of negative 81, which is the same as this. Of course, again, you can use this, but it's a little bit longer than just by using this formula that's already presented to us. So we are just going to use the same formula to the rest of the given here. Let's proceed to number 2. Again, we need to identify the correct coefficients. So A here is again 1. B is now present as we have negative 4 being the numerical coefficient of the term with x. So you have negative 4. And then C is not around. We have here 0. So we are expecting to use A and C coefficients because our formula is again given as C over A. Surprisingly, our C is 0. So no matter what the value of A, but in this case it's 1, the product will be given as 0. So in this case, the product of the roots is 0. Just for the purpose of representation or demonstration or just for reference, let's just try to solve the roots for number 2. We won't be using or we won't be solving the roots anymore for the rest of the numbers, but for this, just to verify if it's really 0 here. This can be solved, or the roots for number 2 can be solved using factoring. Specifically, common monomial factoring, when you factor out x, and you will have x minus 4 here equal to 0. We won't be using extracting square roots because we already have rather the b coefficient. In this case, we will be using the zero factor property, which means that the entire expression be equal to 0 if any of the factors or both are equal to 0. So the roots are 0 and positive 4. And of course, if you're going to multiply them, you will get 0, which is the same as this. So again, you may still use the factors, but you could just simply jump into the formula to get the product of the roots. Let's go to number 3, 4, and 5. In this case, let us try to refrain ourselves in solving the roots, and we will just try a separate video for the roots themselves. The formula here is again C over A, and the correct A, B, and C coefficients for number 3, and by the way, 3, 4, 5 are all complete quadratic equations. In short, all are present. A is 1, B is 4, and C is also 4. Even if B is no longer needed here, it's always nice to complete the coefficients as practice. So the product of the roots is 4, this 4 here, not that one, over A. So the product of the roots is 1. If you are not sure, you may try to use the factoring here to solve for the roots and determine if the product is really 4. Number 5. By the way, in number 4 and number 5, we have the same first and second terms. They only differ on the last term, which is the constant. In the previous video, the sum of the roots are just the same as it uses the b coefficient for the formula and a coefficients. So we have same a and b coefficients here, only differ with c. But for now, since we are now using c for the formula, and here a is again 1 and b is 4, but c is now 5, this means the product would be different from between number 3 and 4. So the product of the roots again is computed by c over a. Again, it's a. So the product, let me remove something here so that it would really look like a. So you have 5 over 1. So the product of the roots is computed as 5. We are very lucky for numbers 1, 2, 3, and 4 since all of our a coefficients are 1, and we just simply pick the value of c. Nonetheless, we will have this formula, but we had the same result. But for number 5, our a coefficient is now given to us no longer 1, but it's 2. The b coefficient is negative 8, and c coefficient is 3. So the product of whatever the roots this will have, you may use the quadratic formula or factoring if it's possible. If it's not, again, you may use quadratic formula completing the square method. But either way, the point for this video is the product. So it's c over a. You will get the result when you divide 3 by 2. So your product of the roots is 3 halves, right? No need to give a value in decimal notation, but of course it's equal to 1.5 or 1 and 1/2. But for us to practice the sense of fractions, since not all fractions can be expressed as terminating decimals, especially if you have denominators of 3, 7, 6, 9, so on and so forth. So let's stick with what is the answer as a fraction, and even improper fraction, no need to have it as mixed. So this is how we solve the product of the roots using this formula derived from the relationship of the variables inside the quadratic formula. Thank you for watching. Please use this as part of your review. Goodbye, everyone.